So in this video, we'll be going over sample question 38 from the Society of Actuaries ExamP list of sample questions. The question reads, an insurance company insures a large number of homes. The insured value X of a randomly selected home is assumed to follow a distribution with this following density function. Given that a randomly selected home is insured for at least 1.5, calculate the probability that it is insured for less than 2. Okay, so we have the following. It's asking us the probability that a home, which the insured value I'll just say is X, right, given there, is less than 2, probability that X is less than 2, given that X is greater than 1.5. And our conditional probability formula should give us the following. Probability that X is between 1.5 and 2 over the probability that X is greater than 1.5. So no real tricks here. This is a very straightforward problem. First, we want to figure out, okay, the probability that X is between 1.5 and 2 for the numerator, and we're given the PDF. That simply means integrate. Okay, so here, let's see, I'll write here the probability that 1.5 less than X less than 2. So in order to get a probability from the PDF, the density function, we integrate 1.5 as our lower bound, 2 as our upper bound, and we're integrating 3x negative 4 dx, right? And no weird integration tricks here. It's very straightforward. It's going to be equal to, just making sure nothing weird's going on here, right? Because this does seem kind of too easy. It's going to be 3 over negative 3, x raised to the negative third, evaluated at 1.5 to 2. Right? Which is simply just negative x raised to the negative third to 1.5. And let me make sure that is good. So it's going to be 2 raised to the negative third negative 1 over 8 minus 1.5 raised to the negative third. So that's going to be a negative 8 over 27. And then I subtract negative 1/8. Now I'm just using my calculator so I don't make an embarrassing arithmetic mistake. Negative 8 over 27. And that's equal to 37 over 216. All right, and that's going to be our numerator. Now, our denominator, admittedly a little bit trickier. So evaluating this, so the probability that x is greater than 1.5. My bounds for that would be 1.5 to infinity, and I do not want to deal with that. So I can do the opposite. This should be equal to 1 minus the probability of x being less than 1.5, which is the same thing as x being between 1 and 1.5. So those are my new bounds that I want to evaluate with. Okay. And let's see, where's the function? 3x to the negative fourth. I know that's going to end dx. I'm eventually going to end up with negative x to the negative third, 1.5. I know 1.5 from the previous step is negative 8 over 27. And I subtract by evaluating at 1, which is just negative 1. Right? So negative 8 over 27 minus negative 1 is 19 over 27. And that's my denominator. So my probability here should be equal to 37 over 216 divided by, sorry about that weird edit, I just realized I had left something out. I forgot the one minus there. That's super important. So although this equals 19 over 27, right, this should end up being 1 minus 19 over 27. Super important because I almost got the wrong answer that way. So 1 minus 19 over 27. That gets us 8 over 27. And that ends up being my denominator here. 8 over 27, while my numerator is 37 over 216. So I do that division there, and I get a final answer of, let's see, 37 over 64. And it's to 3 decimal places, and it's approximately 0.578, which lines up with answer choice A. Okay, so overall, not a terribly difficult problem. Obviously, you know, everyone's susceptible to small mistakes, just careless kind of things, forgetting a 1 minus. But basic idea was you want to find the probability within an interval. You have the PDF. You just integrate within that interval. If there are any questions, leave it in the comments. I'll answer them to the best of my abilities. If you want to see more worked out problems like this, I have a playlist. And if this video helps you out, hit the like button because that definitely helps me out. Other than that, good luck, guys.